So this next 6 sessions, for which the schedule is as follows: Tuesday, Thursday and Friday, same slot from 11:15 to 1:15. And we all the coordinating TAs, Harshvardhan, Advay, Krunal and Rupanjan will be taking, Suketu also will be taking this on behalf of him. Sir may be present or not, but what the purpose of this is, keep post Sir's lecture which happened last week. We are taking peer discussions which you all have prepared, and doubts and any kind of discussion which you want in that particular module. So for today we have planned, sir, and we have planned module 1, which is system properties and signals in Fourier domain, where the it's like 11:35. So from 11:35 till 1:15 there will be peer discussion where all the group leaders will come, and those who are prepared for these two module only, signal properties, basics of signals and signals in Fourier domain, will come discuss their way, their topics, advanced topics, or if any question are there. And if time is left, we'll open the whole panel for discussions and doubts, so that there is no chance of any doubt and infamiliarity for this particular two modules. Same with Thursday, I will explain. For Thursday, we will covering module 3 and 4, Z transform, stability and sampling theorem. And for Friday, what we all have prepared for the first half, it will be problem posing sessions by all these TAs and a few more small assignments. And in the second half, as all of you were having this doubts or inclination towards mini project or assignment, practical assignment, so I have prepared two type of assignments which I will demonstrate here and share those files with you all on a WhatsApp group only. One is on Python and one is on GNU Radio, which I will discuss more on Friday. So now I will like to call all the team leaders who are starting. Pattern would be like, let's say if sir is starting, sir will introduce himself, as all of these lectures are recorded, so it will be for all of our personal good. Sir will come, sir will introduce, and we'll start with the topic. Okay.
Okay, good morning one and all. Good morning class. Thanks for being here, and thanks for giving me the opportunity to introduce myself and start this peer learning session. In Indian National Academy of Engineering and Infosys Foundation conducted Center for Engineering Education Excellence, known as CEEE program, being conducted by AICTE and IIT Bombay. So myself, Saurabh Mitra, I am a faculty in Gogte Institute of Technology, Karnataka, Belgaum. So I will be initiating the session. This is from module 1, a brief discussion on little bit fundamentals in signals and systems, not the entire thing. So this is a kind of outline of my presentation. So initially I will check the basic introduction to signals, then systems, one property which is called as size of the signal. So energy and power signal, this is a topic sir has covered in the class, so I will just conduct one or two examples how to calculate it. Types of signals, not the entire thing, it will be conducted by my friend Dr. Srinivas, but whatever I require, analog, digital, continuous, discrete, whatever is the basic difference in that I will cover. Then mainly I will be touching upon the example or application that is called as system modeling, which is my main domain of research and teaching that I am doing. So in our institute there is a course called a skill development course. So being the Spock of MATLAB, MathWorks, I am doing a lot of work in signal processing for UG level. So I have just taken a system which is called as a hydraulic system. So two responses sir has already conducted, one is called as natural response, another is called as step response. So these last two topics are the main thing that I would like to share with my peer. Initial topics more or less it has been discussed, but to go to the last topics I will be requiring some help from the initial topics that I will discuss first, and as soon as possible I will go to the hydraulic system, natural response and step response. So this is the outline of my presentation. Now there are three categories, as Dr. Gadre he has shown, that some people who have taught these courses for many times, Some people who have taught this course for once or twice, and lastly the faculties who have gone through this in their UG days, but they have not taught it. Okay. So I will try to keep the level as average. So those who are pro in this, maybe the initial few slides will be very trivial for them, but anyways. So this is signal. We have seen the definition in sir's class. So TV signal, telephone signal, then monthly sales in any shopping mall or chain like DMart and all. So they are also a signal example. Daily opening and closing prices of stock market. So it is a highly dynamic, highly volatile kind of system. So there whatever signals we are generating. So in one word, the signals are actually the functions of the independent variable time. But not every time we will find that time is the independent parameter. Any example from anybody who can say any signal which is not defined over time? So what can be the other independent variable? Yeah, that is an example, but it is defined over what? Space. Okay. So there are mainly two types of signal in our domain which we process. One is we call as temporal, and another is called as spatial. So with respect to space, so another example of space, with respect to space, if I want to define a signal, like you can say the population density. Okay, so population density of Bombay is very high, Kolkata it's very high. You go to Arunachal Pradesh, population density is very less, because you will be finding homes or houses after every 3 or 4 or 5 kilometers. So population density can be a signal which is defined over space. At the same time, population can be defined over time as well. So 2011 population of India was this much, 2021 population of India is this much. So population density is over space, and population as a count can be over time. So this is the definition of signal. Then this may not always be the case, that is time may not always be the parameter, it can be space. One example I have given at the end. So whenever we are showing time, whenever we are showing signal, sorry not time, it is generally we are giving xt, that is equal to 3t plus 5. Okay. So you can substitute t from 0. So if you are substituting t as 0, then this is x axis, this is time. When t as 0, signal can be 5. When I am substituting t as 1, it can be 3 plus 5, that at 1 it can be 8. Okay, then 2, then 6 plus 5, 11. Okay, likewise we are going to get a straight line. And here we are calling this as xt. So this is a signal, this is a linear signal, and it looks like 3t plus 5. So see the parameter, it is xt is equal to 3t plus 5, it is a linear signal. Very quickly I will go to systems, because I will be developing a system, I will be finding its transfer function. Definition of system, it is called as, it is correlating input and output. So system process the signal, they modify the signal to extract additional information from the input signal. So it is a mapping between input and output. For an example, aircraft gun operator. Aircraft gun operator means I am here, I am finding there is coming some plane from the opponent side. I have to track it, I have to latch it, and I have to destroy it. So first I should know whichever plane is coming from there, I have to detect by my sensor, and then I have to track that thing, and then I have to latch that, and then I have to shoot from my side, and I have to kill that. So this is the whole process. So this is the whole system. Now approximately estimate the future location. So this is the job which is being done by this aircraft gun operator. Now everything is automatized nowadays. So he has to just see, latch, and then destroy. So main job this system is carrying out is approximately estimating the future location. So it's a predictive kind of a system. So system is an entity, this is the definition, that processes a set of signals or inputs to yield another set of signal or output. So it is an input output mapping. Now here I have given the same example. So the same example, it is called as yt is equal to 3xt plus 5. So this is yt is equal to 3xt plus 5. So here this is the independent variable, here this is the signal is represented by xt, this is called actual signal, and here this is called as a system, where this is called as response, we don't call it output or input. Okay, so we have to use more purified words for our students, and this is we call as, you can say, stimuli. Don't use the word input. Okay, so there is trigger, stimuli, and other kind of things, source, those are the things we use. So you can see here the difference. Okay, so this is yt is the output, xt is the stimuli, and now you can tell me whether this system is a linear system or the system is a non-linear system. It's written here. So I have given example of two non-linear system. One is called as yt is equal to 5x square t. Why this is non-linear? Very easily you can find out. Yt is equal to 5x square t. Now see the graph. Okay, so with respect to t, I give here yt. So at 0 it is 5 0. So I am just doing yt is equal to 5x square t. So when xt is equal to 0, so you can say that this is a xt yt map. Be careful. Okay, so here independent parameter is xt. So I have given input as xt is equal to 0, yt will be 5x square t, so yt will be 0. When x is equal to 1, at that time y will be 5. Okay. When x is equal to 2, at that time y will be 20. X is equal to 3, yt will be 45. So if you see, the graph will be somewhat like this. And it's non-linear in nature. So we know that yt is equal to 5x square t, it's a non-linear, or it's a kind of a square kind of a curve, it's a non-linear thing. Easy to understand. But if I give you another thing which is written here, so this is for the faculties who are, so it is given here 3xt plus 5, this is for the faculties who are yet to teach this course, they have done it in their UG days. So it's a linear system or non-linear system? Non-linear. Why non-linear? Because there are a lot of linearity things we are studying from the very first day. Is it because of that? Okay, so linearity, as we have studied in Gadir sir's class as well as in Debsattam sir's class, the system actually has two properties. One is homogeneity, scalar multiplication, and superposition. So how I prove it? Okay, so how I prove it? If you see sir's lecture in NPTEL or some other faculty's lecture in NPTEL or not, so what they are doing is they are giving input. So proof is very easy. You give input as x1, so you get output as y1. So this is 3x1t plus 5. Similarly, you give another arbitrary input x2t. So what I find is y2t is equal to 3x2t plus 5. So this is scalar multiplication property is kind of satisfied. Now what we have to do is we have to, so here we are giving the input separately. Now we have to add those two inputs at the outside and then we have to give it to the system. So y3t is the output when the inputs are added externally, that means superimposed on each other externally, and then given to the system. So this will be 3 of, now input given in this case is x1t plus x2t. So this is 3 x1t plus x2t plus 5. So this step is where generally students get confused. So we have to be very clearly, we have to tell it. So you have to take first input, give to the system, generate the first output y1. Give the second input, generate the second output y2. What is y3? Take the same inputs, add them externally, then feed it to the same system. Actually, what is the system doing? The system is an amplifier. An amplifier output is being given a DC shift of 5 volt. So whatever input you take, the system is amplifying it by a factor of 3 and then giving a DC shift of 5. This is the system. Now this system is linear or non-linear. That is what we are supposed to find out. Up to 3xt it was okay, because multiplying by 3 is a linear process, but as soon as you are doing plus 5, that might add some non-linearity. So just check whether y1 plus y2 is equal to y3 or not. If this is satisfied, this is called linear. If they are not satisfied, it is called non-linear. So if you are adding y1 and y2, we are getting 3x1 plus 5 plus 3x2 plus 5, and right side we are finding 3x1 plus 3x2 plus 5. So 3x1, 3x2, 3x1, 3x2, no problem. But here it is 5 plus 5, 10. Here only we are having 5. Okay. So only because of this part, plus 5, we say that this left side is not equal to right side. Hence the system is non-linear. Okay. Same thing you can do for 3x square t. Whatever I had given for 3x square t here. So you will be finding this is 3x1 square t. Here also you will be finding 3x2 square t. And whenever you are adding the input externally, you are finding this is x1 plus x2 square. Okay, so this is 3x1 square plus 3x2 square plus here an extra term is coming, that is called as 2x1 x2. That is getting multiplied by 3, so that will be 6x1 x2. So here also you will be finding y1 plus y2 will be not equal to y3 because of this term. So hence this system property is a non-linearity. So only this part I will use, remaining properties sir will cover. So proving for linearity, non-linearity, time variant, time invariant, causality, non-causality, all these things are part of systems and signals syllabus, and very clearly we have to explain it to the students with proper example. Okay. So now this system is also called as conditionally linear. This system is also called as conditionally linear because that plus 5 is there, that is kind of an offset, it can be compensated. Okay. So but this system is non-linear that we are calling. This is one property I would like to tell you, that is what is meant by size of a signal, because I am going towards a explanation of stability. Okay. Size of a signal can be given by its amplitude, its size is in the y direction, or it can be given size in the x direction. Signal is prolonged, that means it is defined over quite a longer period of time. Okay. So both the things can be, so it is signal amplitude or signal duration, both can tell me about the size, size of a human being. Now sir has told about abstract. Okay, so what is the abstract? Whatever he was teaching step by step, 3-4 concept he was teaching, and then he was asking what is the abstract thought out of these 3-4 processes. So abstraction is very much required in research, and what is meant by abstraction is what is the gist, what excerpt you can find out from all this process. So abstract here is, I am just assuming human body to be like a cylinder, because if I want to model, there are some abstraction required, there are some assumptions required. Okay. So if I am assuming myself or human body like a cylinder, then there will be a cross sectional area, there will be height and all, and then you are finding volume, which is pi 0 to h, h is the height, r is the diameter of the body. So that way you are trying to model the human body as a process, and you are finding what is the volume. So here the abstraction is, we are assuming the human body to be like a cylinder. Another very important thing, so signal energy, how to find the signal energy. First you have to understand what is the amplitude of the signal, then square it. Okay. And if it is complex signal, it has to be squared with a mod here. If it is a real, it is like this, x square. I will share the book, I will share the PPT, so all the PDF and PPT, everything is there, I will share it with you. Very important thing, if you are finding that this area under the curve, so if I am giving you a signal, now I am deviating from system, I am just giving you a signal, whether I am trying to find out whether it is a stable signal or unstable signal. So if I give you this signal is xt, this is 2 and this is 3, stable signal or unstable signal. Fundamental is very simple. If you tell this, lot of things will be clear to the students in signals and system, control system, and lot of communication related things will get clear. It's a stable signal. Why signal is stable? Because whenever you are trying to find the area is half into 2 into 3, that is 3 square unit, okay, and this is a finite number. So whether I can find its Fourier or not, whether you are going to find its Fourier series or Fourier transform. Why not series? Because it's a one-off kind of a signal, okay, with time period of infinity. So it is not a repetitive kind of a sequence. So it's a one-off signal like that. Then you have to find its Fourier transform. So all these basics, whenever we are doing module 2, it might be useful. So just now some question is given in the exam and students are directly find its Fourier series. They are not checking whether it is integrable or not. So whenever I am saying that, whether it's an energy signal or power signal or what is the finite energy, first you have to find how much is the area under the curve. If I am finding this area under the curve is finite, that time I can go to find its spectrum, or I can convert this thing into Fourier domain. If I give you this kind of a signal, how much will be the energy? So shortly you are going to find it. If I give you e raised to minus something t, okay, it starts from 1, whether it's a energy signal or power signal. It's an energy signal. Why energy signal? Because this area under the curve, is finite. We call it asymptotes. Okay, so this is getting asymptotic with respect to this. That means they will meet each other in infinity. So this is what is called as asymptotes. How to find how much is the energy? So you are having this e raised to minus at, so 0 to infinity, e raised to minus, or you can say that simply e raised to minus t, so you have to square it and it's dt, that's it. So whatever is the signal given, square that signal and integrate it over the time period which is given. So here the time period is 0 to infinity. So how to find whatever is the energy of that? So e raised to minus 2t will be e raised to minus 2t divided by minus 2. This is the integration. This is 0 to infinity. Then this minus I will remove. So this is half e raised to minus 2t infinity to 0. So I have removed this negative. So I have exchanged this limits. So e raised to minus 2t. So this is 1 minus 0. Okay. So this is e raised to minus 2t. If you are putting 0 here, so this will be e raised to minus 0, that is 1. If you are putting infinity, this is e raised to minus infinity. E raised to minus infinity is 0. So this energy will be half. Unit is a must, it should be joules. Okay, so how to find the energy? Very important thing, very easy thing, but you tell this very clearly to the students and it will change a lot of things, because a third semester, I am not talking about IITs because students of us are not in IITs. These people are groomed in a different way. Okay, very fast, very beginning, they go in the mathematical way, but our students have to be explained things with respect to numerical. Okay, so as soon as we are solving one numerical, as soon as we are showing them, then it goes inside the head like this. So is this understood? How to find the energy? Just know this, because I will give you a very small numerical, you have to solve very easy numerical just to boost your confidence. So square the amplitude, first square the amplitude, see what is the function given, square that thing and then integrate it over the base, whatever is the time period over which the signal is defined. So here the signal is defined over 0 to infinity, that is what I have taken from 0 to infinity, and e raised to minus t, e raised to minus 2t, I will just change it, I will make it e raised to 3t. Then what is the thing? You have to make it e raised to minus 60, that's it. And then accordingly you have to just solve it and whatever answer comes. Okay. So last line is very important. If the area under the signal curve is finite, that means if it's an enclosed area, so bounded input we say. What is meant by bounded? This area is bounded by how many things? It is bounded by x-axis, it is bounded by y-axis, it is bounded by the signal. So it should be a closed area. It should be a closed area. As soon as you find it's a closed area, it's a finite energy. Signal is a energy signal. How much is the energy? You are finding it to be half joules. So then this is called as a bounded input. So this kind of thing if I give to a system. Now if you are trying to find out system stability. This kind of input if I am giving to a system, if the system is producing another bounded kind of area, then that system is called as a stable system. Bounded input you give to a system. I don't know what is a system transfer function, I don't know how the system works, but this kind of bounded input if I give to a system, it produces a bounded output. As soon as you are saying bounded output means what is the unbounded output? This is the unbounded output. Can you calculate the area over time t0 to t infinity? How much is the area under the curve from t is equal to 0 to infinity? It is infinite. So you are giving this kind of input to a system and the system is producing this kind of output. That means that system is a unstable system. But if you are giving this kind of input to a system and system is producing this kind of output, so for bounded input it is producing bounded output, means system is a stable system. This is the concept. The whole control system at UG level is guided by this stability. The same stability we are finding from root locus, same we are finding from Bode plot, same we are finding in the time domain, trying to find it in frequency domain. All the criteria we are finding in that way only. So root locus we are finding the stability in S domain. Bode plot we are trying to find the stability by using frequency domain. X axis is log omega and we are doing that. Understandable? Energy signal. Then is coming this signal, understandable energy. Okay, it is starting in the left side but it is going in the too much deep into right side, but this area you can see it's a finite area, it's a confined area, so it's an energy signal. Energy signal, okay, is it an energy signal? It's a non-causal kind of a thing, so here it starts in the left side and going in the right side, so there is anti-causal, causal part, non-causal, all those things. Okay, so here signal starting from 0 and going in the right side, it's called as a causal. But signal starting in the left side and then crossing the 0 and going to the right, it is called as a non-causal. So anti-causal, causal, non-causal, all those things. So here there are two parts actually. Here there are two parts. How much is this? How much is this area? Or what is this signal actually called? This signal is called 2. So how to find the energy of this thing? Should we do this numerical? Ekdam bahut simple hai. In one line it can be done. So this signal has to be divided into two parts. So 0 to 2. First find energy of this. So minus 1 to 2. So how much is what is the actual signal? The signal is 2. It's a kind of a pulse kind of a thing. Okay. What is the difference between pulse and square? So this is pulse. Okay. So this is another way of showing the ground level. Okay. So here let's say this is 2 volt pulse and this is a 3 volt. This is a negative pulse, this is a positive pulse. So pulse is unidirectional. Okay. But if I am saying this kind of thing, there is a square wave if area A is equal to area B. Okay. Then we are saying that it's a square wave. So this is 0, this is 3, this is minus 3. Can you find its Fourier transform or you will find its Fourier series? Why series? Because this is a repetitive waveform. So first we have to understand this. I am touching few more things. So we want to check its frequency content. Now it's a repetitive kind of a thing. It's a periodic signal going from 0 to infinity with some kind of time period, right? So you want to check its frequency content. Whether you will find series or transform, you have to find series. For this, whether we can find Fourier series, answer is no, because this is not a repetitive function. We have to find Fourier transform. While you are finding Fourier transform, what is the period you have to take for this? Time period. Time period is taken as infinity. Okay, because this is the on time, maybe 0 to 3, and off time starts from 3 to infinity. Again at infinity it starts repeating. So there are many concepts like that. So for this kind of one-off signal like this, we find Fourier transform. For repetitive periodic, we find Fourier series. Just looking at it, can you tell me what is the value of A0? We find A0, AN, BN, right? A0 is 0, Looking at it, you have to tell me A0 is 0, A0 is 0, A0 is 0. It is 0. Why 0? Because this positive side, all the positive halves, okay, so whatever happens for one period happens for other period also. Okay, so we'll be finding that this area is this area, this height is this height. So wherever there are positives, they all will be having a positive DC. Wherever there are negatives, they will be all having a negative DC. And this positive DC and negative DC, they will cancel each other. So it will be having the value of A0 as 0. If you see, the Fourier series can be solved in half a page. That is how this IITians do. Our students solve a lot. We just keep on using properties. Because they are very thorough in their head about the properties. Big solutions. So when I was TA for some subjects, they used to solve 10 mark question in 3 lines. Third property they used to write and done. Okay, whether it's a even signal or odd signal. If it's a even signal, then some sine or cosine, which is not there. Sine part is not there. If it's a even signal means it's all defined by cosine. So sine components will not be there. If it's odd signal, then sine parts are there, cosine parts are not there. So we don't calculate A0, AN, BN all. Okay, we just put properties. So this kind of thing, this area same. In that case, we will be finding A0 is equal to 0. So what is A0? A0 is the DC component in the signal. So if I give you another rectangular wave like this, okay, so this is 0, this is 4.5, this is 2, then this is 7.5 and this is 3. How much will be the A0? And then it is repeated. How much is the A0? Again A0 is 0. You can calculate. Here you can say, sir, this time is, so this is 0, 2, 4, 3, 3. So this area is this. Here also we will be finding that 0 to 4.5. How much is this area? This is 9. Here how much is this area? This is 3 and this is 3. So this is also going to be 9. So positive area and negative area, they will cancel each other. And whatever is a positive DC, whatever is a negative DC, they will cancel each other. So there will be a positive DC, there will be a negative DC, cancel each other. So net DC will be equal to 0. So if you see the GATE question papers, very simple things are there. Okay, so you can set this kind of questions. It's very interesting. So such very small problems posed to the students, they'll get interest, right? So here I have found for this, here I am finding the energy for this. So amplitude is 2, this is 2 square from 0 to 1 dt. This will be the energy. Is it understandable? Find how much is the amplitude, square that and integrate it over the period. So what is the period? From -1 to 0, it doesn't matter, 0 to 1, because energy, if I give you one signal like this, -1 to 2, another signal I give you here, 0 to 1 of 2, they will be having same energy. Because it is shift invariant, whether you shift it, you fold it and these and that, anyway you are finding the area under the curve as same. So this is the way if we teach, instead of just bombarding with them with the formulas and all, okay, so it will create more impression. Okay. So how much is this? So this is 4, so this is 4t and this is 4 into 1 minus 0, so this is 4, this is very important, 4 joules. So student, don't write units, I cut half a mark. Once I cut in the initial stage in the minor exam, they will not make the same mistake in the major. Okay. So this is for this part, this is the energy. And next, for the other part I have shown you, so what will it be? So from 0 to infinity it will go, and this is 2 e raised to minus, so this will be 4, so square this, 4 e raised to minus t. So 4 e raised to minus t dt, again the same thing, so this will be 4 e raised to minus t, this is 0 to infinity, again it will be 4. So the second part also 4, first part, so total energy is 8 joule. Very simple numericals, but with lot of insights. So this is how it is given. So first part is this, find the amplitude, square it, Second part is 2 e raised to minus 2, square it, then integrate, then you are finding it to be 8 joules. Stable, it's a, can I say it's a bounded input? Bounded, because the area under the curve is totally bounded. It's a energy signal or power signal, it's a energy signal. So if the energy is finite, it's a energy signal. Can you get how much is the energy of this? All are energy signals, right? How much is the energy of this? So find the area first. So this is 2 square, 2 square is 4, and again that is integrated over 0 to 1. So we will be finding the first one is 4 joules. How much is the energy here? So 1 into 1, that is 1, square of that 1 integrated over 0 to 1, it is 1 joules. Last, this one. नहीं, वो mistake मेरा भी होता था. Answer is 4 by 3. Answer is 4 by 3. So first thing is from 0 to 1. First thing is from 0 to 1. So this point is 1 comma 2. Okay. So first is to find what is the signal. First is to find what is the signal. So it is starting from, so I am finding for this. So it starts from 0 0 and goes up to 1 comma 2. So you have to find xt is equal to something of t, okay, plus it will be 0. So how to find? This is x minus x0, so y minus y0 divided by y0 minus 2. This is x minus, this one. Initially what I used to do was, so I will tell you the mistake, half into 1 into, this is 2, half into 1 into 2, this is 1, 1 square, that is 1 t, 1 joule. This answer is wrong, I am telling you, no? No, because I am proving it. I am just proving it. Okay, do you agree this is t? It's 2t. Do you agree this is 2t? So let us find out this. Okay, let us find this out. So how to find it 2t? Because this is a line, so y minus 2. So this is y minus y1 by y1 minus y2. That is okay. So this is t minus 1 divided by 1 minus 0. So this is y is equal to 2t. Somewhere it will come y is equal to 2t, right? So this is the signal. So don't be in hurry. This is 2t, signal is 2t. So this is 4t square. This is square of the signal. Now you have to integrate it over 0 to 1. I was doing the same mistake as you were doing in my student life. Because I was doing half into base by height. So that was 1. 1 square is 1. Integrate over 0 to t. So I was finding 1 joule. That is wrong. First find what is the signal. Okay, so signal is y is equal to 2t. Square this, 4t square. 4t square has to be integrated over the base, that is 0 to 1. So you will be finding this is 4t cube by 3. So that is 4 into 1 by 3, 4 by 3 joules. Always follow this process, get the signal, square it, integrate it over the base. See, we understand the theory better when we are solving a numerical. That is what I do. And this signal and this signal, they are shape wise, they are kind of same. You just shift it in left side by 1 unit. So if you do x3 and if you just do 3 plus t plus 1, then you are going to get this x4. So x4 is a shifted version of x3. So then you will be finding that x4 is coming left. Okay. So the same answers, it will be 4 by 3 joules and 4 by 3 joules, it is like this. So these are all about energy signals. Then signal power. Generally for periodic signal we are finding the power. This is the formula for real. Yes. Whatever thing I show you hydraulic system, there whenever you are doing the natural response simple, that is what I'm telling. एक bucket में पानी भरो, okay, just एक bucket में पानी भरो, नीचे एक hole मार दो, so पानी धीरे धीरे जा रहा है, exponentially it is reducing. Anything that is exponentially reducing. Capacitor, once you charge it, mobile, if you can charge and just keep it, don't use it, okay, धीरे धीरे it will flow, so exponentially it will decay. एक आदमी को एकदम भरपूर खिलाओ, so I give this very crude example, एकदम भरपूर खिलाओ उसको, eat to the extent, and फिर बाद में उसको घर में बंद करके रख दो, धीरे धीरे his life will come down and at t tends to infinity, it won't go to infinity and die. So anything natural response, it is going to be energy signal. Okay. Whenever we are finding some kind of periodic signal, it can be a power. So again, if it is generalizing formula, here this is the difference, the x square. So for complex thing, we are trying to find the square mod of that. Energy or power. So you have to remember, whenever it's a kind of a periodic signal, this is a generalized statement, whenever it's a periodic kind of a signal oscillating with respect to 0 and going like that for infinity, okay. So this kind of signal, it's going to be a power signal. Not periodic zaruri nahi hai, but okay, all periodic signal whichever are oscillating like this kind of signal, it's a power signal very easily. But this kind of thing which is not going too much into high or low, but it is oscillating with respect to a certain, not necessary with respect to 0, but ऐसा up down कर रहा है and till infinity it is stretched. Yeah, it can, a periodic signal cannot be all aperiodic. So this is a periodic signal. It is not energy signal. It is not energy signal. No, let me do energy, power, and the third case. So this is the second case I am into. After third case, it will get clear to you. So this is the second case. First is energy. Let me tell all the cases, then you will get your answer on your own. Okay. This is a periodic signal. Is it a energy signal? No. Okay. So, but if it is decreasing like this, then it will be energy signal. So it is not about periodic or aperiodic. Something else is there. You just have to check whether it is increasing, whether it is building up, or it is coming closer to ground. So this is coming closer to ground. Sorry, that signal. There is a kind of oscillation here for finding power. How to find power? You have to find how much is the base width. You have to find how much is the time period. How much is the time period? So from here it is starting. This is positive half, this is negative half. So time period is 2 seconds. So in that case, how to find the signal power x? So it is half. Why this is half? This is 1 by t. So 1 by t. So first we are supposed to find out what is the time period. Now I have seen, my experience, students understand this better as a period rather than this. Okay. So starting from one lowest point to another lowest point. So or one highest point to another highest point. Because in MATLAB and all, whenever we are trying to calculate, this is the way better we calculate. So this is 1 by 2 stretching from -1 to +1. So this and this. So -1 to +1. This signal is x square t. I don't know what is xt. Then again the same thing, y minus y0, x minus x0, all those things, find the line equation. And this equation will be t. So again the same thing, t square. So as we had been doing in case of energy, the same thing you do. So this is square of the signal from the time period. Only thing is you have to do is joule per second you have to do. So previously it was only joules. In this case you have to do joule per second, because the total energy kind of thing you are finding, that you have to divide by time. So joule per second whenever you are doing, you are getting watts, and this has to be finite. So in this case the power is 1 by 3 watts joule per second. So differentiate energy, you are getting power. So that is another interpretation. And if this is a power signal, what is going to be its energy? So you have to go in the reverse way. So don't try to find it. If it is 1 by 3, then you integrate it and going the reverse direction, it will be infinite. So whenever it's a periodic kind of a signal, finite, This is a power signal, and whenever it is enclosed kind of a signal, we don't find power, we find energy. So just looking at it, you should be able to tell me energy or power. So 3 signals are given, all are periodic with basic as omega naught, that is the baseband frequency. In this case omega 1, omega 2, both are power. So together they will be preparing another third signal which also will be a power signal. Last case d e raised to j omega naught t, d e raised to j omega naught t, this is also a power signal. So these are the powers that you can calculate by the same way. So in this case the power will be in this case, so what kind of signal is this? D e raised to j omega naught t. So e raised to j omega naught means cos omega plus j sin omega. Okay, so this is not a simple exponential, this is cos j plus, sorry, cos omega plus j sin omega. In that case it will be d square. So these are some of the things, and few cases. Energy or power, energy or power, again it is repetitive kind of thing. So what we do, how much is the time period? Time period is 1, so it is square of the signal. How much is the signal? Can you just prove it? 0.4324, 2 line का equation है. So it is e raised to minus 2t, e raised to minus 2t dt 1 by 1, that's it. So e raised to minus 2t means this will be e raised to minus 2t by 2. So I will change the limit from 0 to infinity. So this is half, this is e raised to minus 2t or e raised to 0, okay, minus e raised to minus 0, no, e raised to 0 nahi, this is from 0 to 1, I am sorry. So this is from 0 to 1, okay, so this is from 0 to 1, this will be 0 to 1, okay. So this is e raised to 0, so if you substitute here, so this is 1 e raised to minus 2. So how much is that? So this is half, and 1 minus e raised to minus 2, somewhere around 0.15 or something it comes. So this is around 0.85 by 2, so that comes to be around 0.4324. Just check e raised to minus 2, how much is that? Comes somewhere around 0.85 or so. Okay, same thing as you had been doing in case of energy, same thing you have to do. So this signal is given as e raised to minus t, square that for one period. So e raised to minus 2 means e raised to minus 2, one period, and 1 divided by the time period. I will give you the book. I am referring from the book of BP Lathi. Again the same thing as BGF sir said, these books are not good for numericals, this many numericals are given, I am solving all them here. But line by line if you read, it will help you in control, it will help you in signals and systems, it will help you understand linearity, all the things, okay, and it starts from the very basic system understanding and goes up to system modeling and all. So this is what it is. Some 2-3 more cases we are going to see. Stable or unstable. Okay, as a signal ut, okay, what is the Laplace? What is the Laplace? Okay, 1 by Laplace, where is the pole? Okay, so stable or unstable, energy or power, and how much is the power? How much is the power? Half watts. I think those who are teaching signals and systems, half watts. Okay, so power, it is a power signal which is called as a half watts, I think. Up check kar sakte ho, you can just, so that's a very small proof, it is asked, so it is little difficult to digest. This is a unit step signal which is a power signal, does not much look like a periodic or something, but it is a power, and power is half watt. See, exponential is a very tricky kind of thing, and it teaches us all. If we understand exponential, we understand everything in signals and systems, and the whole signals and systems are taught by some professors only with exponential signals, okay, in the very basic UG level. You just say A is equal to minus 2, How will the graph look like as a signal? How will the graph look like? A is equal to minus 2, it will be like this, e raised to minus 2t, okay. If you take a is equal to plus 3 or plus 2, go like this, is equal to 3t, okay, and you take a is equal to 0. Ever thought of it? The unit step is exponential signal, okay. So this is e raised to 0t, this is e raised to 0t. नहीं बोलूंगा ना मैं.
What's the power?
Half watt. Half watt. 0.5 watts. Very simple proof, the way sir asked yesterday. But it's very difficult to digest initially. Power, this is kind of thing, but there's a power signal. Just take it with pinch of salt. Madam, now energy or power? Now I am coming to the third thing, it is neither energy nor power. So signals are categorized into this, either energy signal when it is closed or power signal जो एक वैल्यू के आगे पीछे ऑसिलेट होते आगे बढ़ रहा है. It is not diverging एकदम with respect to time, it is becoming big and big and big. No, it is oscillating around some value and going up to infinity. Neither energy nor power. So this is the third category. So any signal you get, you can category. So this signal I have not shown, ramp sinusoid, we can generate it very easily in MATLAB. I'll just show you. So this is kind of a thing, and like this, energy or power, sinusoid, okay, it is sinusoid, but ignore this part, okay, ignore this part, and it is going like this. So one signal I had shown you like this, and the signal like this, energy or power. So it is neither energy nor power, because what you have to say is the actual value area under the curve is increasing as t is increasing, the area under the curve is increasing. Okay. I had a lot of confusion in all this because I have learned this signals and systems looking at sir's NPTEL lecture and all. Officially I learned it. So there all these concepts sir has explained very properly. So you can just check. So this kind of thing, it's a neither energy nor power. So very easily you can confuse students. Now is coming the conclusion. Signal cannot be both energy or power. Now madam, I am coming to your question. It cannot be energy if it is power, it cannot be power if it is energy. And this is the third type, neither energy nor power. So if it's an energy signal, then it cannot be power. If I am saying that energy itself is 5 joules, how much is the power? What is the relationship between energy and power? So power is nothing but energy over time. So if energy is 5, you differentiate it, you will be getting it to be 0, right? So power will be 0 in that case. So if you have found its an energy signal, don't go on finding its power. If you are finding a signal is a power signal, don't go on finding its energy. It's reverse thing. A signal cannot be both energy and power together. There are signals that are neither energy nor power. Ramp signal is one such case. So ramp signal I started that 3x plus 5 like that. Okay, now last discussion on signal and continuous discrete analog digital. What kind of signal is this? Continuous, understood? Are these 4 things same? Continuous, discrete, analog, digital. What is the category? Who is the opposite of what? Continuous, uska opposite discrete. Analog, uska opposite digital. So continuous and discrete, analog, digital, analog, digital. Can you draw? What is the first thing? Okay, I'll just show you this because it is already there. Just tell me the properties. Sir knows, sir was also a pro. Ah, okay. How do you define this? How do you define continuous means at every instant is having some time? How do we define analog? Chalo, this is more difficult. How do we define analog? Nay. How do we define analog? What is the mathematical interpretation of analog? Continuous is different. What is analog? See. It can be discrete analog, it can be continuous analog. Close. So, this also I learnt while teaching, because as a student life, analog can have any levels of amplitude. So, it has nothing to do with time. Don't say anything about time when you are talking analog. Whenever I am saying analog, it means, okay, I will just come to it. This is suppose 2, this is suppose 5, this is t, and this is x1t, this is x2t. Which one is analog? If I say this is signal A and this is signal B, which one is analog? A is analog, B is? A is analog. Okay, which one is continuous? Thank you, very good. So this is continuous analog and this is continuous digital. As soon as we give this kind of thing and ask students the digital thing, no, first thing they should say that it should come to 0. It is not coming to 0, lowest level is 2. So 2 to 5. In digital what we check is, so there is a difference between analog and digital. Analog can have infinite amplitude levels. If I say that this point and this point, let's say this is 2.1 and this 3.3, how many amplitude levels are possible between 2.1 and 3.3? Infinite. That is the definition. We should not talk about time while explaining analog. It is all about amplitudes. Analog means it can have infinite number of amplitude between any two levels. Digital means it will stick to 2 states. It takes 2 states. Definitely there might be mathematical interpretation of all this, but not going to go there. So ekdam normal digital student who has come to 3rd semester, they have studied the 0, 1 digital and all. So it is easier to explain to them, only 2 states, binary. Okay. So this is analog and digital. Then we will be coming quantization. So how many quantization levels are there? So it is said that it is quantized in y-axis. आप 2 से नीचे भी नहीं आ सकते, आप 5 से ऊपर भी नहीं जा सकते. So there is a restriction. So whenever there is a restriction in the y direction, it can go from analog to digital. Okay, very easy, but for that we have to go through the book once or just listen this kind of things. So first whatever I have shown, it is analog or digital. First thing, it is analog. Continuous or discrete? Continuous. Next, analog or digital? Digital. This is continuous digital. So here this is, there is nothing discrete, both are continuous. So this is continuous analog, this is continuous digital. Clear? Is it quantized in y-axis? Quantized means restriction. इससे ऊपर नहीं जा सकते, इसका नीचे नहीं. There is no quantization here. No, that is discrete digital. This is continuous digital. Digital not necessary, it has to be continuous or discrete. I'll come. I'll just show the 4 things. Then you can give your. Okay. Quantized in which axis? Quantized means restriction. Quantized means restriction. इधर कोई restriction नहीं है. There is no restriction in y-axis. If this signal was growing and going to the infinity, this signal also will go to the infinity. So there is no restriction in the y-axis, but in x-axis there is a restriction. That is, you have to take amplitude at every sampling instant. Okay, though it is starting from this side negative, right side positive. Okay, so this is restricted in x, but not restricted in y. So this is analog, but this is discrete analog because this is quantized in one domain, that is x axis. And last one, what sir was saying, again, this is discrete as well as digital. Two levels, this is level high, this is level low, and they are also discretized because x axis there is the quantization. So n is equal to 1, 2, 3, 4, 5, 6. So whenever you just go through this 4 things together and you convince yourself, many things in signals and systems control and for electronics communication or electrical gets cleared. As soon as we ask analog, as soon as we ask continuous, everybody is after this x axis, x axis. So analog means we have to define from y axis point of view, how many levels. System modeling basics. So system modelings can be transfer function, impulse response, state variable model. So whatever we have seen today in the circuit analysis class, it is state variable model actually we have gone through. So we have gone to. So any system can be represented by linear algebraic equation. So x side, left side it is dxt dt, the right side it is ax plus bu. So in that thing, so transfer function based system modeling is what I am going to show you. And there is a example. Sir said there is a canonical form, first order canonical form expression, that what we are heading to. Now this is a system example. This is a hydraulic system, tank with cross sectional area, and this is called natural response. And we will find that this system will not be having any transfer function. Okay. So system, this is height of the water. Initially we have poured some water into it, and then we have opened this valve so that we are getting a Q. Q is the output flow rate, and it can be correlated with analogous to the electrical system as well. So P1 is the top and P2 is the bottom. Generally P2 is shown here. So exactly between the half, whatever is the pressure at that point, that is what is called as P2. R. What is R? R is called as hydraulic resistance. Now as soon as you open this valve, either we get water at very high output rate or we get water at very low output rate. So high output rate or low output rate, that all depends on the value of R, which is called as hydraulic resistance. Okay. So then water flowing out of the tank, this is a system. So P1 minus P2 is the pressure difference between the top and bottom part of the tank. R is the hydraulic resistance, Q is the flow out rate of liquid. Now if you are just trying to find the analogy with electrical system, then V1 minus V2 is the potential difference. This is correlated to P1 minus P2. R is the electrical resistance and I is the rate of change. Okay. Now there are very small analogies. Rho is the fluid density. P1 minus P2 is R into Q. So this is P1 minus P2. How much is the difference? That is actually made equivalent to resistance multiplied by output. So V is equal to IR. That is this equation. P1 minus P2 is nothing but V. You can see here P1 minus P2 is V1 minus V2. R is nothing but resistance and Q is nothing but output current. So this is that V is equal to IR, this equation. Rho GH rings a bell. What is rho GH? So water is stored in a tank till a height of H, up to height of H. And what is rho? Rho is the density and G is the that universal constant we know. So rho GH is nothing but the energy. Kinetic or potential? Potential. So there is a potential energy. You have taken an object and you have kept it here. So now this is the height. So as soon as it is falling on some glass which is kept at the bottom, it will break the glass because of the potential energy. So rho gh is equal to R into minus dV dt. What is dV dt? How the volume is reducing. Okay, so that is nothing but equivalent to what is the output flow rate Q. Now Q is negative. As time going by, you will be finding that the rate is decreasing. So Q is always a negative terms. Now volume is equal to, so this is how I am correlating rho gh, it is equal to R into A into minus dH dt. So this A into dH, so rho gh jo hai, that I have substituted here. So dV, this V is equal to A into H. So if you are doing rho AH, so this A comes outside and this becomes rho RA minus dH dt. So this equation and this equation, they are same, only I have substituted V as A into H. Now you take this equation, both the equation you take in one side and you are forming what is called as a first order differential equation, and rho g by Ra assumed as K, which is the time constant. Laplace in both the sides without any initial condition, you are finding SHS plus KHS is equal to 0. Homogeneous equation, what is meant by homogeneous equation? We are not giving any external input, like I told you that you fill this tank with some kind of water and then everything is cool, then what you do is just open this valve. How the valve gets drained, how the whole tank gets drained out, that will be kind of a exponential thing. So from there you can find out the time constant and all, which will be a function of rho g Ra. What is rho? Is the liquid density, g is universal constant, R is the resistance of this whole system, and A is the cross section of this tank. Okay, so if you are making the cross section of the tank very big, in that case you will be finding that rate of change of height will become slow. So time constant is something which is deciding whether system is going to be fast or system is going to be slow. So the value of time constant which is very less, it will be showing very fast change in the input or output likewise. So time constant and system dynamics. System is fast if time constant is less, system is slow if the time constant is high. So this system will not be having any transfer function because everything is there in the left side. What is the main variable? It is the height of the liquid. The right side there is nothing, no input given. Same system model I can show you here. I will not go much of into depth. So this is all the steps shown here. What is the difference here is I am giving the input. Input is given from the external. So Q1 is there. Previous case it was only Q2. Now Q1 is there. Q1 is nothing but how the liquid is being filled inside this. Now here also in system modeling they are playing some game. You want to add some sinusoidal oscillation. So this is kind of a continuous input that you are giving to the system. You want to add some kind of harmonics at the input, some kind of perturbation you want to give to the system and check. So kya karo? Whatever water is coming out, sometime we can see in the tap, the water is coming thoda आवाज कर करके थोड़ा ऐसा, not एकदम constant flow, गड़ करके कुछ आवाज करके आ रहा है पानी. So that kind of water input is actually called as a perturbation kind of thing. There is a continuous flow and there is a sinusoidal. So you can change this to change the input conditions. So all we are doing in the same way, there is no new parameters. One new parameter is there. So R is the thermal resistance, hydraulic resistance. There is coming a new thing which is called as a C. This is called as a hydraulic capacitance. It all depends on, so C is the hydraulic capacitance, it is a function of A rho G. A is the cross section, rho is the liquid density, G is the constant. So this is the only new thing, C dp dt q1 minus q2. So the same thing as we write the capacitance equation. V, how much is the V? In case of capacitor, how much is V? C di dt or something. So 1 by C integration of it dt. From there you can take the C this side. So I is equal to C dv dt, all those things. So exactly in the same line it is coming. That is what is called as a C. C is equal to A by rho G. If you just keep on substituting this, I will be sharing this so you can have. So this is, here you are finding, this is also a first order equation. Why this is first order? Looking at the system, can you tell me it's a first order system? How do you decide? Very important thing. Today sir had drawn that system, Harish Pillai sir. and very easily he has said it's a second order system. How do you decide whether it's a first order system or second order? Yes, how many energy storing elements are there? So if you are talking about R, L and C, if you are talking about R, L and C, so in circuit theory we don't say R, L, C, we say L, R and C. Why? Because this is having equation as L dit dt, first order. This is R it and this is 1 by say integration of it dt. So it is kind of order 0, order 1, order minus 1. So this is 2, 1 and 0 kind of this thing. Okay. So this is mid. This is not an energy storing element, but this is the energy storing element, this is the energy storing element. This and this are the memory elements, as sir is saying. Different names are there, they are storing energy. MBK system, MBK. What is the equivalence? This M is equivalent to L. MBK means mass, dashpot and spring constant. Okay. So this M is equivalent to inductance, B is equivalent to resistance, K is equivalent to 1 by C. These two are energy storing elements. Dashpot is not a energy storing element. Okay. So whenever I am saying RLC circuit, second order system, whenever I am saying this system, it's a first order system. Why? Because only one energy storing element is there. Okay, this is C and R is there, which is called as a what? Hydraulic resistance. Same thing you can do for thermal also. I am having the model for thermal. So here you are not going to find any hydraulic inductance. Search karo if there is any hydraulic inductance there, because we say that all the systems, they are equivalent to each other. That is what sir asked to find. Sir, he said try to give as many examples as possible. So correlate all these things: thermal, pneumatic, hydraulic, electrical, electronic. What is the electronic thing we are studying? We are studying those BJT, FET and all those things, right? MOSFET. So those are electronic. Electrical is RLC. This is hydraulic. MBK is mechanical. Pneumatic. Pneumatic amplifier is there. Any pneumatic systems we have seen real life? Pneumatic. Pneumatic system is wo jo whenever the people comes in industry, if you go, the way they put the nail into the wall, they don't use hammer, they use some kind of motor, and that motor is not electrical motor. There is a very big compressor. If you go to industries, compressed air comes there, okay, and as soon as they press it, that compressed air comes and rotates the motor and it take the nails inside. So if you visit big industries, there is a huge compressor and lot of things they are doing all by pneumatic motors. Best example, whenever we are traveling outside overnight journey and all by bus, the doors are opened and closed by brakes. So that is the pneumatic open and closing, door closing. In Bombay city also, all the AC buses whichever are there, so their doors are, yes, right. So they are all pneumatic. So hydraulic, which one is having the highest amount of power, energy or power? Hydraulic having huge power, okay, usse thoda kam pneumatic, little bit less mechanical, and electronics is having least, electrical is having little more than electronics, but then also electronics, electrical are preferred over hydraulic for what? For accuracy, for precision, okay, this kind of thing. And whenever it's very huge power and all, excavation and all, so for that we are using JCB. You can see that JCB, they are having hydraulic arms and all. In hydraulic arms and all, there is hydraulic inside, like our body. So I always give this example that inside our body you will not find blood anywhere. If you just open the body or something, ऐसे blood ऐसे पड़ा हुआ, ऐसा नहीं होता. It is all in a very closed system. Blood is there inside the body everywhere, but it is all totally in a closed system, because it is supposed to generate the pressure. It has to take all the food and oxygen to every cell inside the body, and also it is a totally closed system. There is not a single drop of blood spilled inside the body, nowhere you will find. It is like that. Same thing happens in case of JCBs and all. It is a very highly closed system. Thoda sa leakage and all, that will reduce the pressure, okay, like that. So this is the system, and last I will show the output. So this is what it is. Now you can find out Hs by Q1s, so output by input. So for that again do the Laplace transform and all, and finally this is the expression A tau, again tau is coming rho g AR, already we have proved, and this is the response, and from here we can find out what is called as a time constant. So whenever, so here one thing is there, you can find there is no steady state error, whatever is the input the response is reaching there, and 1 minus e raised to minus t by tau, 1 minus e raised to minus t by tau, this is generally the equation of this kind of response, and where t is equal to tau you are finding 1 minus e raised to minus 1, so that will give you this value 0.632. Okay, so where t is equal to tau you will be finding this as 1. So where that t is equal to tau, here exactly the t is equal to tau. So if this is the response, input is 1, output is reaching to 1, so you have to do the whole experiment, capacitor charging. So this experiment my students do, they do almost for 1-2 hours or so, like this, very simple 5 volt DC you give, and this value of R you can set as 1 kilo ohm, this is 10 microfarad or 1 microfarad maybe, electrolytic plus minus like this, and you can leave them in the lab for 2 hours. Just keep on measuring voltage after every 1 minute or so, and this output will never go to 5 volt, this output will go to maybe 4.7, 4.8, 4.9, saturate, stay there. Okay, and after taking all the readings after every minute or maybe after every 30 seconds, then you can plot this thing, because RC circuit, this is also a first order circuit because there is only one energy storing element. So then you can plot this graph after taking the all readings, then you have to plot it. And why to plot? If it is going up to 4.8, then you have to check what is the 63.2 of that. So 63.2 of that. So maybe it is around 3.4 volt. So whenever you are drawing this whole response, so this is the input, this is very close, this is 4.8 maybe, then you just find out, so this is 3.4. This time is called as time constant tau. So this is a very simple experiment, time consuming, student will enjoy. When they will enjoy it? After the experiment is conducted, after they are plotting the graph, then whenever they are plotting this. So this is a RC time constant, it is not about capacitors, it is about RC. So R into C, that is what is called as time constant. So whatever the value of R you have taken, R we have taken as 1K, this we have taken as 1 microfarad, so 1K into 1 microfarad is 1 milli, okay, so this is 1 millisecond is the time constant, or whatever R into C that will come. So we have to select this value quite big, so this C value has to be selected quite big. So this big fan capacitor is there, 420 microfarad or something, or you can take bigger value of capacitor, you select it around 4 minutes, 5 minutes, 230 or 400, 500 seconds, you check this value of capacitor for a very high value, bada capacitor you have to purchase and leave them, and then whatever they are getting time constant, in the next what you do is you reduce the value of this R value from 1K, you make it 470 ohm. So you will be finding that previous case this was the response, now in this case this will be the response. So this was with R value bigger, this was with R value bigger, this one will be R value smaller. So the same thing, 0.632, okay, in this case this will be tau 1, and in second case whenever you are reducing R, this will be tau 2, and tau 2 is less than tau 1 because R2 is less than R1, like that. So a very simple experiment you can do. We do this experiment with RTD also. We are doing this experiment with the RTD, you are taking a kettle and we are giving the electricity, then measurement is being done by RTD, it is a sensor, as well as the measurement is being done by the thermometer. Every 20 seconds we are taking the reading. So two things are happening, temperature is increasing, so we are measuring delta T, and second we are measuring how is the change in RTD resistance, that is called as a delta R, that is also a first order system. So there are 4 processes. First, the inside whatever is the input, that is heating up the coil inside the electric kettle, that is heating the water is hitting the thermometer, and thermometer is showing some increment in the mercury height. Or if you are talking about the resistance process, First the coil is getting heated, then the water is getting heated, then the RTD is getting heated, and then the RTD is showing the change in delta T, sorry, delta R. So you will be finding two graphs there. So you will be finding two R there. One, this will be the curve of delta T, and this will be the curve of delta R. And इसका जो 63% है और इसका जो 63% है, both exactly will coincide at the same place because this is a linear system. Delta T and delta R both are changing exactly in the same way with respect to temperature. So don't tell student initially that whatever is the time constant of the temperature process and whatever is the time constant of resistance process, they will fall exactly on the same line. So after they do all the experiments, then you check what is the final value, multiply that with 63.2, you will be seeing that for both the cases the time constant will fall exactly on the same line. So after almost 2 hours of toil, as soon as you tell them this and they calculate and they find अरे दोनों तो same आ गए automatically, this feels like magic because the system is linear. Delta T and delta R, they change in the same way with respect to time. Is it understandable? Very simple experiment, just an electric kettle you need and a RTD, that's it. So this is what is that time constant, and this is how the time constant is changing. So last slide, all the equations and everything is given here, and this is how we are finding the time constant, and this value is deciding whether the system is fast or slow. Now tau is slow whether it's good, or sorry, tau is big whether it's good, or tau is small whether it's good. So there is no answer. There is no answer. It depends on our requirement. Depends on our requirement. Okay. Sometimes the teacher is very fast, students are slow. There is no point in that. Sometimes students are very fast, but teacher is slow. That also does not serve our purpose. Okay. So our speed should be same. Our speed should be same. So whose speed can be modulated? That's why we are controller. So whenever I am saying controlling process or control systems, they are the process, and every year we are getting a different students with different bandwidth. We say that yes, 1993 batch was excellent, 1995 batch was not that good. Okay, this batch is average. So it's all about our perception. We don't remember one thing, that our speed of delivery is reducing every day because we are every year we are teaching, we are getting more knowledgeable, we are maturing, so we can handle different kind of classes. Our expertise is increasing. With respect to that, if we trying to measure all the students, no, it's not good. Okay, so that's why I have seen very big professors, you give them any audience not knowing anything or audience too much knowledgeable, they can teach all the people with the same ease, because they have reached in such a position of their teaching career. You give them any audience and anybody and everybody, comfortably they will teach, and at the end everybody will say, ah, kya, it was a aha experience kind of thing. Right. So that is our goal, we should go to that extent. So this is where I have left you, and I'll be sharing all this. Any questions expected? That's it. Thank you.
So you will know that there are 5 important properties that were discussed of systems: additivity, homogeneity, causality, shift invariance, and then stability. Yeah. So these are the 5 properties. Naturally, in order to convince yourself that they are in fact independent, you would need to construct 32 different examples of various combinations. So, is there a system which is causal and stable, but it's not additive, it's not homogeneous, it's not shift invariant? So you need to construct these 32 examples. And another question is, can you devise a system which depends on some parameter S, and if you change that parameter S, the system changes its properties? So suppose that I have a parameter S, and if I put S equal to 1, then the system is additive. If I put S is equal to 2, then it's not additive, but it's homogeneous, and so on and so forth. So this is one of the questions that you will need to solve in order to convince yourself that these properties are in fact independent. So it's not key, if my system is additive and homogeneous, it needs to be stable. It's not like that. So you need to do this, And please prepare some of the examples, if not all the 32, by the next time we meet. Yeah.
And all of this जो जिन्होंने बोला will be shared on group also.
Yeah, I'll be shared on WhatsApp.